At the heart of electromagnetism lies a fundamental balance of how a field moves through space, often described as a conservation of structure. This balance is captured by a specific identity that relates the way a field swirls upon itself to its internal stretching and its overall curvature. To understand the foundation of this relationship, one must look at the mathematical framework known as index notation. Rather than treating a field as a single arrow, this method breaks it down into individual components using a specialized language of symbols. Within this system, certain symbols act as substitution operators, functioning like logical switches that allow mathematicians to swap and reorganize different directions of movement. By carefully tracking these indices, a complex, double-swirling motion can be systematically simplified into two distinct, manageable parts. The identity reveals that a vector field has three primary ways of changing. The double swirl, this represents the curl of the curl, or a measurement of how the vortex-like swirling of a field is itself rotating or changing through space. In fluids, this is often seen as a sign of turbulence or highly twisted flow. The stretching effect, known as the longitudinal part, this measures how much a field is expanding outward or compressing inward at any given point. Imagine water suddenly appearing at a source and pushing outward in all directions. The diffusion part, also called total curvature, this measures how much a specific point in the field differs from the average of its immediate neighbors. This effect is usually associated with smoothing or dissipating energy, similar to how heat spreads out